Hi everyone, this is the second part of the earlier question, which asks us to show that the circle touches the y-axis. So when we have the circle touching the y-axis, it means that the x-coordinate of the point is 0. So we're going to investigate what happened to the equation when x is equals to 0. So this is the equation that we will end up with after simplification. This is what we will get. And most of the time, students will actually go ahead and solve this equation to get the value of y. However, I'd like to suggest using another approach, which is to consider your discriminant b squared minus 4ac. If you do not know what discriminant is all about, maybe you have forgotten this concept in the topic of quadratic equation, or maybe you might not even have learned this discriminant before. So what does discriminant tells us in short is the nature of roots in a quadratic equation. And a, b, c will refer to the coefficient of your x squared, x, and the constant respectively. So if I were to apply for this question, my b will be negative 24, my a is 1, and my c is 144. When I key into the calculator, I get the value of 0. So therefore I conclude there is only one real root. So which means to also say there is only one solution of this quadratic equation. That means there's only one value of y when x is equals to 0. Therefore, since we only get one value of y, we conclude that the circle touches the y-axis. Thank you. I'll see you in the last part of this question in the next video. In the last part of this question, we need to write down the equations of the tangents to the circle, which are perpendicular to the y-axis. So in order to answer this question really quickly and easily, I will suggest a diagram. So this is our circle. Center is 10, 12. Now, when we have tangents which are perpendicular to the y-axis, so basically this is your y-axis, this is your x. If it's perpendicular, that means we have horizontal tangent. So what I'm going to do is I'm going to add one horizontal line here. This is one possible tangent, and the other possible tangent will be somewhere here. Now the thing that you have to be aware of is radius will be perpendicular to our tangent. So this will form a 90 degrees. In other words, we can know for sure the y-coordinate of this particular point here, because the radius of the circle is 10, which we have found out in part A as well, which means to say this point is 10 units above your center, which has a y-coordinate of 12. Therefore this point will be 22. And you don't even have to find the x-coordinate, because we just need the equation of line, which means to say the equation will be y equals to 22. With the same idea in mind, the other tangent, which is at the bottom of the circle over here, it will be 10 units away from the center of the circle. So comparing the y-coordinate, this point here will be 2. Therefore, the equation will be y equals to 2. So these are the equations of the tangents to the circle, which are perpendicular to the y-axis. I have finished the three parts of this question, and I hope it gives you a clearer picture of how we approach circle question. I'm sure you agree with me that it is highly application, whereby we even have to bring in concepts from other topics. I hope you enjoy the videos, and I look forward to producing more useful content for your learning. Thank you.